Hi students, welcome to physics class. Today we will discuss about dielectrics. The dielectrics are insulating materials which transmit electric effects. These are the insulating materials. Dielectric materials are insulating materials which transmit electric effects without conducting electricity. They will not conduct any electricity but they transmit electric effects. We know that based on conductivity, materials are of three types. First one is conductors, second one is semiconductors, third one is insulators. We know that the conductivity of insulators is equal to 0. Whereas in the case of dielectrics, these dielectrics are insulating materials, but they will transmit electric effects. This is a special case. So we will study these dielectric materials. These dielectric materials are two types. First one is non-polar and second one is polar. In the case of non-polar, the positive and negative centers will coincide. In the case of polar, the positive and negative centers will separate. There exists a separation between positive and negative centers in the case of polar, whereas in the case of non-polar, the positive and negative centers will coincide. So, the net dipole moment, here P is called as electric dipole moment. Electric dipole moment. This electric dipole moment in the case of non-polar dielectrics is 0 because the positive and negative centers coincide. The examples of non-polar are O2, CO2, CH4, etc. Here these non-polar dielectric materials are symmetric in shape. Symmetric. Let us consider an oxygen atom and another oxygen atom. In the case of oxygen molecule, then there exists a symmetry. Whereas in the case of polar, the positive and negative centers are separated, then there exists electric dipole moment. That is, the electric dipole moment should not be 0. Examples of polar dielectric materials are HCl, H2O and NH3. Let us consider water molecule which consists of an oxygen atom and two hydrogen atoms. Here there exists an asymmetry. There exists an asymmetry in the shape of polar molecules. So dielectrics are two types. First one is non-polar and second one is polar. Now we will discuss about non-polar dielectric materials in detail. Let us consider a non-polar dielectric material in which the positive and negative centers will coincide. We know that the positive and negative centers in the case of non-polar dielectric material will coincide. Here we have depicted non-polar dielectric material. Here K is called as dielectric constant. Here K is called as dielectric constant. We already know that the electric dipole moment in the case of non-polar materials is 0, because the positive and negative centers coincide. So there is no electric dipole moment. This is in the case of when there is no external electric field. This is only in the case of when there is no external electric field. Let us suppose these dielectric material, non-polar dielectric materials are placed in an electric field E0. E0 is the electric field between the plates of a capacitor of initial capacitance C0. Let us consider a capacitor of capacitance C0. The electric field between the plates of the capacitor is E0. Now we will place this dielectric material, non-polar dielectric material, in between these plates. We know that in a capacitor, one plate is positively charged and another plate is negatively charged. Then the electric field direction is towards negative, from positive to negative. When non-polar dielectric material is placed, then there exists a separation between positive and negative charges, positive and negative centers. That is, these non-polar dielectric materials gets polarized by the external electric field. As a result, the neighboring positive and negative charges will combine and gets nullified. These positive and negative charges at the neighboring atom will coincide and gets nullified. Finally, there exist only negative charges on the surface and positive charges on the surface. That is, negative charges are formed on the surface where there exists a positive charged plate, and the positive charges are accumulated on the surface of dielectric where there exists negatively charged capacitor plate. As a result, induced electric field is created. The direction of induced electric field is towards positive to negative, from positive to negative. Here EI is called as induced electric field and E0 is the electric field between the capacitor plates. This is the external electric field. This is the induced electric field. The net electric field can be calculated as E net is equal to external electric field minus induced electric field. External electric field minus induced electric field. This value is equal to 1 by K times the initial external electric field. Let us say the electric field between the capacitor's plate is 10 volt per meter initially. If K is equal to 2, then E net will be equal to E naught by K, which is equal to 10 by 2, which is equal to 5 volt per meter. This is the net electric field. The net electric field we will observe here is decreased from 10 to 5 volts. So the net electric field is equal to 1 by K times the initial electric field between the plates of the capacitor. As a result, there will be decrease in the voltage also. This decrease is similar to the decrease in electric field. So V is equal to V naught by K. Here V naught is the initial voltage between the capacitor plates and the net voltage is given by V naught by K. We know that C is equal to Q by V. As the voltage decreases, the voltage between the capacitor plates decreases, the capacitance of the capacitor increases. This is the main principle involved in the working of a capacitor. By decreasing the voltage between the plates of a capacitor, we can increase the capacitance of a capacitor. Here, by introducing non-polar dielectric material between the plates of a capacitor, finally we get a decrease in the voltage. As a result, there will be increase in the capacitance by K times. Here, K is called as dielectric constant. So, the capacity or the capacitance of a capacitor will be increased by K times, that is increased by dielectric constant times the initial capacitance. This is all about non-polar dielectric materials. And we will also discuss about polar dielectric materials. In the case of polar dielectric materials, the net dipole moment, electric dipole moment is not equal to 0. There exists an electric dipole moment because the positive and negative charges are separated. The positive and negative centers are separated. Here we will observe the electric dipole moment exists for this atom and the dipole moment direction is like this. For this atom, the electric dipole moment is like this. For this, the electric dipole moment is along this direction. Finally, the net electric dipole moment will not be 0. Net dipole moment will not be 0. When there is no external electric field, these electric dipole moments cancel out each other. So, the net dipole moment will be 0 initially when there is no external electric field. When the polar dielectric materials are placed between the plates of a capacitor, similar to non-polars placed in a space between the plates of a capacitor, in the similar manner, these dipole moments gets the direction of external electric field. All the dipole moments will align in a direction of external electric field direction. Finally, we get a decrease in the electric field and also decrease in the voltage. As a result, the capacitance of a capacitor will increase in the case of polar dielectric materials also. So, by introducing a polar or non-polar dielectric materials between the plates of a capacitor, we can increase the capacitance of a capacitor. Thank you.